Hello there, and welcome to week 2 of BUSU 610. This week we're going to be talking about chapters 2 and 4 of your course textbook. I'm your instructor, Harjit Singh. Chapter 2 talks about describing, both are on describing data, chapter 2 and 4. So, but chapter 2 covers the frequency tables, frequency distribution, graphic and graphic representation. We'll cover all about a frequency distribution actually, and various ways to use frequency distribution. And chapter 4 is about displaying and exploring data. And in other words, we will be exploring data visualization using various techniques. Objectives for chapter 2, we will learn how to summarize qualitative variables with the frequency and relative frequency. So we will be learning how to use frequency and relative frequency tables to organize qualitative data into classes that are both mutually exclusive and collectively exhaustive. Okay, so when I say mutually exclusive and collectively exhaustive classes, what does it mean? I think we will talk about that later, but let's first go through the objectives. The second objective is learning how to display frequency table using bar or pie chart. You probably are familiar with the bar and pie charts. They're pretty commonly used. A bar chart displays data with the bars representing class frequencies, and a pie chart shows the proportion each class represents of the total. Okay, and third objective is to summarize quantitative variables with frequency and relative frequency distributions. In this case, we will be learning how to create frequency and relative frequency distributions for quantitative data, showing how data points are spread across various classes. And objective 4 includes displaying frequency distribution using a histogram or a frequency polygon. Frequency polygons or histograms are used to represent quantitative data distributions graphically. A histogram displays data in contiguous bars indicating the frequency of each class. So you plot data as it comes in a frequency plot, histogram, while a frequency polygon connects the midpoints of each class with lines to show the overall shape of the distribution. That's what we're going to cover in chapter 2. Chapter 4 we have is we're going to look at in chapter 4 we will learn how to construct and interpret a dot plot. Chapter 4 is focused on data visualization. So we will talk more about that dot plot, what it is and how it is used. And second objective is identifying and computing measures of position. Like, we may divide the data into various parts for better representation, right? So better visualization. So we'll define position different positions like quartiles or deciles or percentiles. And then third, we will look at the box plot. A box plot provides a graphical summary of data distribution with the interquartile range highlighting the middle 50% of data points. And there, it also allows us to show outliers and skewness. Okay, the fourth one is we're going to look at the skewness. So skewness is when we have outliers, and that shows how the distribution is skewed to one side or the other side. So it could be positive skewness or negative skewness, and there are a couple of techniques we're going to talk about how to quantify, how to compute a skewness, and how to plot it. Objective 5 is about creating and interpreting a scatter diagram. A scatter diagram is a correlation diagram where you have two variables and they are correlated or not. It shows whether there is a correlation or not. And finally, the contingency tables. We will talk about that to analyze the relationship between profit and dealership. With the example we will take, and showing how it basically is used to cross tabulate two categorical variables to show how they interact. Okay. Now let's talk about the first topic, chapter 2, about frequency table, frequency distributions, and graphic presentation. Frequency table. So what is a frequency table? This is a method of grouping quantitative data into distinct classes or bins. For example, if you have a data on car sales by location, you will group the sales into different location categories, right? Oh, I was going to talk about a mutually exclusive class and collectively exhaustive class. So this is something you need to understand. It's related to creating classes. Mutually exclusive mutually exclusive class. What it is. It means that each observation or category falls into only one class. In the context of the diagram, each circle represents a different class, and no overlap between the circles signifies that an observation can belong to only one and only one class. For example, if you are categorizing types of fruit, an apple can either be in the apple class or in the non-apple class, but not both. And collectively exhaustive, what it is? It means that all possible outcomes or observations are accounted for in the classification system. In the diagram, the entire area within the boundary represents all possible observations, ensuring that there is a class for every possible value. Using the fruit example, as we saw before, you would need to ensure that every type of fruit falls into one of the defined classes. For example, whether it is apple, banana, orange, or something else. Okay, now how to construct frequency tables. So first one is sort data into classes. So you need to make classes of the data first. Okay, define the classes and shove data into that, and count the number in each class. What is that? Count frequencies, basically. Tally the number of observations within each class to determine the frequency. And number 3, report as the class frequency, what it is. So report, um, so like for example, car sales by location. So you have a location Kane, Olean, and Sheffield, and Kion Nesta. So you see number of cars sold in each location, 52, 40, 45, 43, and total we have. This is a frequency, basically we can call it a frequency, 52, 40, 45, 43, and then the classes are this Kane, Olean, and so on, the classes. And total we have is 180 if you add them up. So now, next step is we have to convert each frequency to relative frequency. So how we do that? So take each frequency, like 52 for Kane, we divide by the total, right? 52 divided by total, it gives us the relative frequency. Similarly, 40 divided by 180 gives us 0.222, and so on. So what you do is now when you finish doing all these 4 rows, you add all the relative frequencies also. They should all add up to 1, right? Relative frequency shows the percent of each in the total, right? So this is how we find frequency and relative frequency. So next one is a graphical presentation of qualitative data. First one is a bar chart. A bar chart. What is a bar chart? Bar chart visualizes the frequency table by displaying data with bars whose heights correspond to the frequency, class frequencies. The chart helps to identify the mode or the class with the highest frequency, and mode is basically the highest frequency, right? In this case, if you see that which one has the highest frequency, so Kane has the highest frequency, so that's the mode in this data set. Pie chart. A pie chart represents the distribution of data set in terms of percentage, showing how each class contributes to the total. And you see that 90. So different percentages are given here in this pie chart. So you have number of vehicle SUVs sold 72, sedans 54, and so on, and total of 180. And percent sold, so 70. So percent sold. That's 72 divided by 180 multiplied by 100, and that gives you 40, right? And then 54 divided by 180, then multiplied by 100 gives you 30. 9 divided by 180 and multiplied by 100 gives you 5. The total adds up to 100. So this is how pie chart is. You can draw this with Excel. Excel. You can draw any type of chart with Excel. So how to construct frequency distributions? First of all, you need to group quantitative data into mutually exclusive and collectively exhaustive classes. So in this case, what we do, so we will follow step-by-step procedure. Number one is decide the number of classes. So we need to find the number of classes first. That's the first step. Then we need to find the class interval. Okay, how the distance between one class to another. Third one is we setting the class limits. How much should be in each class. Then fourth one is tally the data into classes in each class and determine the number of observations in each class. So basically what it means is organize the data into these classes and count the number of observations. So this is a data set. There is a large number of items here in data set. and if you see that there are two slides here for this data set, and the maximum in this data set, the maximum number is 3,292, and the minimum is 294. So you need to find that. That's what I'm saying. This table is about from your textbook. So profit on vehicles sold last month by the Applewood Auto Group. So what we do is, frequency distribution. What we need to do is, number one step. So we need to decide on number of classes. How we find how many classes we need. So the rule we used is 2 power k greater than n rule, where n is equal to 180. What is 180? 180 is the number in a data set. So all these numbers are, if you add them, all these numbers 1, 2, 3, 4, 5, and so on, in 2 pages here, they are 180. So in this case we need to find the value of k that makes this relationship true. So in this case, if we go all the way up to 7, k power 7 gives us 128, right, which is less than 180. And when we do 2 to the power 8, that gives us 256, which is greater than 180. So that holds true. So in this case, we will be using k is equal to 8. So 8 classes. And second step is we need to find the class interval. And the formula for class interval is maximum minus minimum value divided by number of classes, k. So in this case, we already identified max and min in the data set, and we get a 374.75 interval, and we can round it up to 400. So now we can use this class interval to use the class limits. So we had like a 400. Basically, 400 is start with the 200. Remember, the minimum is 294, so we can start with 200. So 200 to 600, because each class is interval is 400. So 200 to 600, 600 to 1000, 1000 to 1400, and so on. So we have 8 classes, and we have the 8 classes and covering all the data elements here, data set. Okay. And now frequency. So what is the frequency? If we look at the data set we have, so how many are between 200 and 600? 8. So if we look at this data set back here, this data set, if we observe that actually we have in this data set between 200 and 600 we have 8, and between 600 and 1000 we have 11, and so on, and total add up to be 180, because total number of elements in the data set, they are 180, right? So this shows the frequency, how often each number occurs within the data set, right? Each value that falls between this range or this range or this range, and so on. Okay, so we found that now, so we can use this here frequency. That's a frequency. Now we can find the relative frequency doing the same procedure we used before. So 8 divided by 180 multiplied by 8 divided by 180, then 11. This one is 11 sorry, not multiplied. 8 divided by 180, then or 11 divided by 180, 23 divided by 180, and it gives you relative frequency numbers around in this column here. And they all should total should add up to 1, because everything is percent and add up to be 100%. Everything should add up to 100%, right? So that was about frequency, relative frequency. Now, graphical presentation of frequency distribution, and histogram is the frequency diagram. And what we do need to do here is draw histogram. So what is a histogram? Histogram is a bar graph where each bar represents the frequency of a class. The bars are adjacent, showing continuous data as it comes. Okay. So then we have a, I mean, we can show with example here. Same example that we have been using. So we had profit 200 to 600. We have a number of occurrences of the values between this range, 8, and so on. And we can use Excel to plot this like this. So we have frequency on this side and profit on this side, and this shows like almost like kind of a normal distribution. Yes, you can see that. So this is a graphical presentation of frequency distribution. Okay, plotting that using Microsoft Excel, and we can also use polygon. Polygon. What is frequency polygon? It's a line graph connecting midpoints of the histogram bar to illustrate the shape of this data distribution. Basically, what we can do is we can, like a midpoint is here for this. Like first bar, we have midpoint here. The second one, we have midpoint here, here, like that. And we can draw a line through the midpoints, and that will show you the overall shape of the curve, right? So, and the graph we get this way is called frequency polygon. Okay, and this is more descriptive, means like a when you visualize the data, actually graph, it looks like a more appealing, and also kind of gives you a good, very more like a meaningful view of the data. Okay. So this is how it looks like. So we can connect the midpoints of each of the bars, and this is how it looks like, right? And we can also use this for if we have two different dealers and the profits, we can show both of them simultaneously. One color, another with another color. So that you can do that also. We can also use cumulative frequency distribution where let me show you this here. So cumulative, you have less than 600, less than 1000, less than 1400. How many are in the data set? You capture that here, cumulative. But this is so first you start with the 600. So you have 8. Okay. So why we need to use cumulative frequency? Because thing is, if something is under 600, right, then it is also under 1000, right? And whatever is under 1000, it is also under 1400. So that way we can actually build this cumulative frequency. Initially, to start with, less than 600, we have 8, right? And that's the first interval we are looking at. And the second interval we have 1000. How many are less than 1000? So less than 1000 in it. In first two intervals together, right? In here, first profit in first band and second band, add those 8 plus 11. So 8 plus 11 here. Then everything under 1400, that is first one, second one, third one, all added together, and so on. They all need to add up to the total, which is so. So this is how we find the cumulative frequency. Then you can, in a similar fashion, you can find a cumulative relative frequency. So once you have the cumulative frequency, then you divide the first entry with the total, right? and then a second one divided by the total, third one, and so on. So you see that 8 divided by 180, 19 divided by 180, and so on, and those you can show the percentage, and they all should add up to total 100%. So once we have that, we can plot this, and with the help of this, we can make many decisions. Like, for example, profit on vehicles sold last month. So we have this green line here showing plotting these values. We see it here, and then we can see, okay, number of vehicles sold on this side, percentage of vehicles sold on this side. This is the profit. You can say, okay, if a number of vehicles sold are 60, then how much profit they map to. We can go this way and check when they touches this graph here, go down here. So this is the profit related to 60 vehicles sold. Now we can say here actually, okay, for this number here, whatever it's like, say 1900 something, uh, what is the percent of vehicles sold for this profit? We can go draw this line here and this line here, but it intersects here. So this is a, let's say it's 55 or 6, something like that, or a number like this, close to that. And we can also see, okay, if we have the, if a percentage of vehicles sold are given to us, like 75%, then how much profit they map to. You can draw this line here, and it shows how much profit this number maps to. So we can visually use the visualization of data to draw many inferences and make many data-driven decisions. So that was all about chapter 2, frequency distribution and relative frequency distribution. Now let's talk about the next chapter, chapter 4, displaying and exporting data. In this case, we learn first of all a dot plot. So dot plot construction. So creating a dot plot to summarize the distribution of a single variable by stacking dots along a number line. So this will give us clusters and gaps in the data, right? So let's look at this. Like this is the data here, data plots. So what we have here is we have the data that displays the number of vehicles served at 2 dealerships. There's a dealership of Ford Lincoln and this Staffield Motors Incorporated. So number of vehicles served at 2 dealerships on different days, and we can use these values, and what we need to do is we need to create a dot plot. So let's see next slide how we create dot plots. You can use software like Microsoft Excel for that purpose to show this. I mean, you need to have a data analysis tool pack installed, and once you have that, you can use Microsoft Excel to achieve this. So here you have, I mean, just let me walk you through step by step. If you see this here, you have some, I mean, your 24 here. This is 23, 24, 25, 26, 27, 28, 29, 30, and so on like this. This is these are the various values in the data set. Okay. So you look at the minimum, look at the maximum, and try to create a scale with that. So now along this scale, you look at the numbers, how frequently they happen. So for a Pure Nesta, 23, how many times in Pure Nesta? 23, one here, and you see that it's only once. So we have only one dot here. How about 24? Do we have 24 in this data set here? We have a no 24 in data set. So we skip it. And now 25. How many 25s we have here? We have 25 here, and there is only 125. So there's only one dot here, right? How about 26? 26 we have 1, and there's only 1. 26. Now 27. 27 we have no 27 here, no here, 1 here, and 1 here. Last we have two 27s. 27 2 here, right? And 28 we have first one here and second one here. So 2. So we have 228. So in this fashion, you keep plotting this like this on the, it's called on the line. You keep stacking the dots, penny. So that means this number here, 32, is 4 times in the data set here. To stack them, and 33 is 2 times, and 35 is 3 times. Similarly, you do the same thing for Sheffield, right? So this is if you do manually, but software can do it for you, right? So what is the beauty of that? Like you can visually look at, rather than looking at this data like this, which is more readable. A picture is worth 1,000 words. So this is more readable. If you look at that, the dot plot helps you visualize data and to interpret it very, very easily. Now, next one is a measure of position. In this case, we compute quartiles, deciles, percentiles to describe the location of data points within a distribution. These measures split data into equal parts, such as the median, or median is what? 50th percentile, right? So we divide a data set into equal parts, allowing us to locate specific points within the distribution. For example, first quartile, Q1 is the first quartile, is the value below which 25% of the data falls, right? So 25%. And Q2 is a median, is 50% of the observations occur up to this point. Then Q3 is 70%. Q3 is 70%, right? And this is the max. This is the minimum of data values. Okay, this is how we. This is a very basic way of measuring the position of dispersion data. Okay, and we can use this in various ways. So deciles means we divide the set of observations into 10 equal parts. Okay, and percentile is dividing the set of observation into 100 equal parts. 100 equal parts. So the formula we use for that purpose is LP equal to n plus 1 in parentheses multiplied by p divided by 100. Well, LP is what? Refers to location of a desired interval. Now, if we are looking for like a 92nd or 36th percentile, that's what it means. And let's take a look at actually how to use this in the next slide. So you have this data set here. It says the commissions earned last month by a sample of 15 brokers. So you see that the profits for first broker is this one, for second broker, and so on. So these are 15 values. Now we need to find the median, the first quartile, third quartile, because we have to draw this this kind of diagram for that. Okay, so we need to sort. If you have to find a median, number one step is to sort data from smallest to the biggest or largest. So smallest is 1460 and largest is 2406. So when we do that, we need to find the middle value. So it's a 15. 15 means 7 on one side, 7 on the other side, and middle one is a 15. So 1, 2, 3, 4, 5, 6, 7. And what is this value? 2038, right? So the median is 2038. Now we need to find Q1 and Q3 and also median. So what is the formula for that? We have the formula here. We're using this one, right? Okay. And in this case, what is a P? P is like a Pth percentile. So we have 25th. So first quad is 25 percentile. Then middle one is 50. So we use these values here. So we'll use these values. Q1. So n plus 1, n is 15 plus 1, 20, for Q1 value is 25, and we get is 4. Oh, by the way, there is one mistake here actually. This one is not, this is 75% here, not 70. Value below which is 75% observation occur. It's not 70. So median is 50%, 50 percentile, so use value 50 here. When we solve this, 8, and Q3 is 12. And so with using this data, we found Q1 position and a median position, middle position, and also Q3. And that's all we need actually. And we already know the min and max. So we can complete this diagram using those numbers. We can create a box. This gives us a box plot. So you have a minimum value here and a maximum value on this side, Q1 and Q3 and middle. And the area between Q1 and Q3 is the area where we have the most of the points. So this is a median of that. So box plots are used to visually display the distribution of data based on 5 key statistics: minimum, first quartile, median, third quartile, and maximum. And when we use this, this helps us identify the spread and skewness of the data, as well as it also helps us to know the outliers, right? Okay, so the range is Q3 minus Q1. So Q3 minus Q1 is the range. So if you have a data set like this, Q3 minus Q1 is range, and then we have median of 50%, and outliers we find on the upper side. This is the formula for that: Q3 plus 1.5, Q3 minus Q1, and then this is for lower side: Q1 minus 1.5, Q3 minus Q1. Okay. All right. So various software like Excel. There is a mini tab. There is other SPSS statistical tools you can use, but Excel can do the job actually. If you have a data, what do you call a data analysis tool pack installed. So various shapes of skewness can be drawn with Excel. So if it's totally symmetrical, you see that there's mean and median coincide, overlap, because it's totally symmetrical. Whatever is on the left hand side of the mean value, same is on the right hand side of the mean value. In case of positively skewed, when the shape is like this, it's positively skewed, like skewed on this side. And in this case, median is always more than mean, because mean is skewed or pulled on this side, right? And negatively skewed shape is like this, where in this case median is bigger than yeah. So the median sorry, in this case median is more than mean. In this case the second one, median is less than mean. So in this case, bimodal, you have the mean in the middle here. So it's shaped like this. The shape is like this. Okay. I'll also share with you a video which I made to how to draw this using Excel. So there are techniques like called Pearson and software skewness. In Pearson, you have the formula like this: stage equal to 3 times mean minus median divided by S, and it is between minus 3 and 3 typically. So if it's minus 3, then there is a there is a there is a negative skewness. 0 means symmetrical. If it's 3, it's like it's like a considerable positive skewness. Okay. And but most commonly used formula is this formula here, right here, software skewness. And let's look at how it is used. You don't have to use this formula. It's very cumbersome by doing by hand. You can simply use Excel. In Excel, there is a command also. If you have data set, you can simply use command called skew, SKEW, and that will give you the skewness. But if you have to plot, like show the shape of the curve, then you have to follow a procedure. I'll show you how to do that. Okay. So let's see. The earning per share for software companies are given here. This value, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? So what we need to do is the first step is we need to find mean and median and standard deviation, 3 things, right? Again, Excel can do that for you, but just want to show you the steps here. Then we have to find the coefficient of skewness, and they say what is the conclusion regarding. So this example I show you what is how we do that. So you have this data set, the values given here, earning per share from the previous step here, and you need to use that formula that I was talking about here. In this data set, when we use Excel to find the what do you call descriptive statistics, it gives us a mean value here 4.95. Median is the middle, which is 3.18, and standard deviation is 5.22. So we got value of S, we got value of median, and we got value of mean, and these are all various values of X here, right? Because sigma means summation, so X this represents any value of this X. Since n is 15, all these values are 15, and we can use this relationship here, and we can use the cumulative value or sum of all these values here. Actually, it comes up to be 11.8274, and what we get is 0.975. So that shows that this is skewed toward right hand side, and is here mean is greater than median. Mean this is a condition for right skewness. Mean greater than median, and if this graph is created by using Minitab, but you can use Excel also. What you need to do is you need to create a histogram, which is a frequency diagram. Then you can draw, or you can simply use a scatter diagram type of chart. It'll give you shape like this. That shows you the shape. This shows the skewness. This shows you this kind of shape as you saw before. This shows this right skewness. The data is skewed to the right frequency, right? So this is the skewness coefficient 0.97, which one we saw here actually 0.97, right? This is the YouTube video I created. on how to plot a frequency distribution skewness using Excel. Uh, you should watch this and learn how to. There are different ways to do this actually. So this is my way of plotting frequency distribution skewness using Excel. So just a good reference document for you to use. Now let's talk about the scatter diagrams. Scatter diagram is it shows the correlation between two variables. Just like algebraic function y is equal to mx fx. So one is held constant, other one is no, actually one is independent variable, other is dependent variable. Y is function of x means y changes as x changes. So the two x and y variables are they are plotted. Here in this case, what we have is a different variable. So we have maintenance cost versus the age, and we have home runs versus the betting average. We have a price versus days on the market. There are various values that you can use. And the shape you see this here, this shows you the positive linear correlation. And this one the last one shows negative linear correlation, and the middle one there's no correlation because here this data is when points are scattered all over the place and you can't make any sense of it. And here you can draw the line of best fit from through these points here, and same thing here also. But here you can't. Okay, that means there is no correlation here in this middle diagram. There is a positive correlation, and this third one is negative correlation. Right? Correlation coefficient measures the strength and direction of the relationship, and this is the formula for that. Again, you don't have to compute using the formula by hand unless you are given some question to use the formula. Excel can very well do for you, and the minimum range is minus 1.0 and maximum range is 1.0. I mean, minimum value for the correlation coefficient is -1, and maximum is 1. If the value is close to +1, it shows the highest. That means the correlation is strong. If the correlation coefficient value is close to -1, it shows the weak correlation. Okay, and if it's 0, then there is no correlation. Okay, so negative correlation shape looks like this. If you see that it has negative slope, it has negative slope, and in pure in ideal form, the R value is -1 here, and this is in an ideal case here. Ideal case means that all data points line up on the line, and in this case, this kind of shape looks like an economics supply curve here and economics demand curve here. So so the correlation coefficient value is 1 here as a positive slope. This is again revisiting the same thing. As you can see this here, there's no correlation, and the correlation is 0.26, which is very close to 0. Now, finally, the last topic is contingency tables. The tables used to classify observations according to two characteristics now. So here we draw the table, and you can see this here. We have profit for 4 dealerships. It shows various dealerships here above or below median profit. So you can this chart shows you that what is the below median profit, what is the above below profit. So you can plot them here in this table like that. So you have cane, Olean, and so on. And you have 25, 20, and so on. These are above median profit, and below is like this. And again, total add up to the same. So 180 is the total. this is a way to show the relationship between profit and leadership. All right, so this was about week 2 um, lecture. And if you have any questions, please let me know. Thank you so much for your attention, and have a nice week ahead.